Okay, I have approximately 7:30 according to my Apple Watch, and we always know they're accurate. Okay, so thanks everybody for attending tonight's meeting. I'm surprised at the number of people we actually have in the audience, considering the weather are getting beat right now. So I'll call the meeting to order for the June and final meeting before the summer break. So as always, I usually start off with a joke or two, and I've got a whole bunch here, but I'm just not sure which would be appropriate for the type of day. So, okay, this is a Captain Kirk joke. How many ears does Captain Kirk have? Well, according to this, a left ear, a right ear, and the final frontier. Bad. Okay. Einstein developed a theory about space, and it was about time too. I know these are bad. Okay. Oh, yes. I'm reading a book about anti-gravity. It's impossible to put down. Okay, that's enough groaners. That's bad. Okay. Okay, so the meeting minutes available in the members area from our last meeting on May the 12th. Has anybody read it? Anyone? Got to be somebody who read them better than me. Oh, we do have. Good. Okay. So obviously, we're not going to have too many omissions or errors. So I'll call for someone to make a motion to accept the minutes as posted. Oh, okay. And you are?
Accepted it.
Okay. You got it? Okay. Talk to Tom. He needs your name. Do I have a seconder? Oh, Jay Lavender will second. All in favor? Opposed? Seeing no opposed, we'll call that a carried motion. Okay. Just going to change the agenda slightly here. At this point, I'm going to invite Jay Lavender and Tom Owen up to the stage. They have a presentation to make.
So we are up here to give out the KELAC Award, which is an award for astronomy outreach and communication. KELAC is the Inuit word that means the entire sky, the celestial sphere, and all that it contains, the sun, the moon, and the stars. In 2010, the Beyond International Year of Astronomy group, which is a collaboration of the RASC, the Canadian Astronomical Society, and the Federation of Amateur Astronomers of Quebec, jointly developed this award. And the KELAC Award is intended to recognize individual Canadian residents who have made outstanding contributions either to the public understanding and appreciation of astronomy in Canada or to informal astronomy education in Canada. So this award, in essence, is all about recognizing those who illuminate the cosmos for the rest of us. It's for the folks who can take the mind-boggling vastness and complexity of the space and make it digestible, exciting, and perhaps most importantly, understandable. So we are here today to recognize someone truly stellar, a man who has dedicated years to looking up, both literally and figuratively. So for years, Jeff Robertson has been a cornerstone, a volunteer at the RASC Observatory here at Telus World of Science Edmonton. He's patiently guided countless curious minds through the wonders in the night sky. He's dedicated years to various roles in the RASC Edmonton Centre, one of which is the Public Education Director, a role he tackles with enthusiasm and professionalism, as boundless as the cosmos itself. But perhaps Jeff's most legendary contribution, the one that truly solidified his place in the pantheon of public astronomy educators, was his monthly What's Up presentations. For years, Jeff spent a colossal amount of his personal time developing these professional grade educational presentations, which became a beloved staple for many individuals of the RASC and the general public who wanted to know more about the night sky. And so with his encyclopedic knowledge and a wit as sharp as a newly ground telescope mirror, he was able to provide all kinds of information regarding constellations, planets, and nebula. He has a real knack for making astronomical concepts interesting and easy to grasp. In fact, I'm pretty sure he could make a black hole sound like a delightful place for a picnic. So without any further ado, as Tom and I sponsored the application for this for Jeff, and for this prestigious award, it is our distinct honor and pleasure to present the KELAC Award for Public Education in Astronomy to the one and only Jeff Robertson.
Oh, thank you. Huh. Thanks, Tom. Thanks, Jake.
Good
I don't
job,
know
Jeff.
who you were talking about most of the time.
Yeah, I don't know.
Show it to the folks.
Oh, yes.
Did you guys all in here?
Oh,
together?
okay. Thanks. Thank you very much. Thank you very much.
Speech.
Speech. But as I'm unaccustomed to speaking.
Unaccustomed to speaking, okay. So back to the agenda. Okay, next on the agenda is the treasurer's report, Jeff Whiten, who will be doing this via Zoom, I hope.
I am. Can you hear me, Clint?
Oh, we got the first page up.
Okay. All right. Am I coming through on the other end there?
Yes, you are.
All right. So, yeah, sorry I couldn't be with you guys tonight. There was another priority here, as I'm sure many of you are probably wondering about too, but I probably should have come and joined the meeting in hindsight. Anyway, so a little bit of activity in this last month. So the general account, we actually had an increasing balance of several $1,000s over the course of the month. That primarily came from the first round of Northern Prairie Star Party fees. So we took in almost $3,000 in Northern Prairie Star Party fees. And there was also about $160 that came into the general account from our membership dues. No expenses at all came out of the general account for the month of May. The casino account, a little more active. We had sort of the major expenses due to our storage locker and our post office box went through. The storage locker is now paid up until I think the end of October of this year. So there'll be another balance before the end of the year. We also got caught up. Once a year, we do a true up with the county, with Beaver County for electricity costs at BNLO. So that came in this year, calculated about $330. Then we had some lingering snow removal costs and volunteer expenses. So the account ended at about $114,700 in the casino account. The Bob Drew Telescope Fund is unchanged from April. Again, there were no expenses put against that particular account in the month of May, so it's still sitting at about $2,500.
Okay, thank you, Jeff. Okay, on to tonight's presentations. We actually have two presentations tonight. We have our own Mark Zalcik, who will be giving us a presentation on Noctilucent cloud. And also after that, we'll have a presentation from Gina Payzant with respect to a movie that she produced and is currently being edited called Physics for Poets.
Good evening. The talk I'm giving tonight is called The Summer of '85 and the New Phenomenon of Noctilucent Clouds. I did it at the Saskatchewan Summer Star Party in 2022, It was the public talk, so I apologize in advance for the preponderance of silly cartoons and animals. This is the Queen Elizabeth Planetarium. It was built in 1960, so as of September 22nd, it's going to be 65 years old. And it was Canada's first public planetarium. And it was also the location where RASC Edmonton had its monthly meetings. Once a month, chairs would be hastily set up in the curved lobby that surrounds the Star Theatre, along with the projector and the screen for the monthly meeting. But there's a problem here. There was so much curvature to the lobby that surrounded the Star Theatre that when they set up the chairs, beyond the 15th row, you couldn't even see the screen anymore. So people obviously came early to get a good seat, and just in case, they brought a Rubik's Cube or a comic book. In March of 1977, the guest speaker was this man, Gordon Patterson. Gordon was a departmental assistant at the physics department at the University of Saskatchewan and was an avid astrophotographer. I was at the meeting. I was only 15 years old. As Gordon was going through his slides, one came up and Gordon announced, "These are Noctilucent clouds, or NLC." I went, "Wait a minute, hold it. Astronomers don't like clouds. The clouds prevent astronomers from seeing what they want to see." Startled, I turned to the person next to me. "I came here to learn about astronomy, and this guy's talking about clouds." This is the right meeting, right? Yeah, good. Oh, thank goodness. What was that? Oh, you like my pocket protector? Thanks. I got it at Eaton's. Anyways, that was in March of 77. 3 months later, I saw my very first NLC display in end of June, 1977. So tonight we're going to talk about Noctilucent clouds, which are mesospheric ice clouds that occur in twilight from these latitudes from mid-May till mid-August, with peak activity at the end of June and the beginning of July. But before we talk about the clouds, let's talk about twilight itself. We never go tired of the beautiful gradation of colors in the twilight sky. This picture was taken with the sun about 8 degrees below the horizon. So starting from the horizon, you have the dark orange layer, which trends to kind of a lighter orange layer. Then there's kind of a creamy layer, followed by light blue and then dark blue. As you get deeper into twilight, any weather clouds that are up there are in shadow because the sun is too far below the horizon. And if you were to have clouds that were lit up in twilight, they would truly have to be very high in the atmosphere. And that's what NLC are. They occur in the mesosphere. Now, a lot of NLC displays are pretty faint, but you occasionally do get some spectacular ones. For example, this is one of the best displays we've had in the Edmonton area in the last 35 years or so. This was July 1st, 2nd, 2011. When I say July 1st, 2nd, I mean evening of the 1st, morning of the 2nd. So yeah, you can see why that they're ice clouds, because they do look like cirrus clouds. They have that feathery appearance. And no need to worry about them being opaque because they're so thin that starlight actually shines right through them. And they tend to take on the colors of the twilight sky that they're in. So towards the horizon, the clouds are orangey. In the middle, they're white. And as you get towards the top of twilight, they have kind of a bluish tinge. So probably a lot of people have seen NLC, but it just doesn't register to them. They're looking at a very unique type of cloud. So yeah, NLC occur at the top of the mesosphere at the mesopause. So right around 80 kilometers altitude, which is the coldest part of the atmosphere, any part of the atmosphere at any time of the year. Temperatures get down to minus 80 degrees Celsius, even as cold as minus 120 degrees Celsius. This graphic just kind of shows the situation with the geometry. Tropospheric clouds are in darkness. The sun is still shining off the NLC, so that's why they show up so brilliantly in the twilight. NLC are composed of water vapor, which is coming up from the Earth's surface. It meets up with meteor dust, which is wafting down from space, and accretes onto the meteor dust particles, as well as ions that are already present in that part of the atmosphere. Now, as I said, they're twilight clouds. So if you see anything illuminated, but the sky is dark, so the twilight's ended, you're not looking at NLC. For example, this is probably just haze that's just illuminated by the streetlights. Now, the part of the sky that you see NLC in is dictated by the how high the twilight arch is at that particular time. If you think of this circle as a celestial sphere, so you're looking straight up and it's just like a big circle with a zenith on top. In daylight or just as the sun sets, it's possible to see NLC, but they're going to be very, very faint because they have to compete with the brightness of the sky. When the sun gets 6 degrees below the horizon, NLC can cover a large part of the sky if they happen to be there. At 8 degrees, they can still be seen over half of the sky. When the sun's 10 degrees below the horizon, NLC are 15 degrees up. When you get down to 15 degrees below the horizon, the NLC are only going to be in a very small patch of sky directly where the sun is. So this picture is taken with a solar depression of about 10 degrees. This is about ideal when you're checking for NLC. The sky's starting to get dark, so you got good contrast with the NLC. And the clouds themselves can be up to 15 degrees above the horizon. So to find NLC, perform the ever popular sky check. Go out, look into the twilight sky, maybe spend a minute or two to get dark adapted. If the NLC are there, there's a good chance you'll see them. If it's a faint, in order to get the faint displays, take a pair of binoculars or get your camera out. NLC are easy to photograph. If you set your camera to ISO 800 with f1.8, you only need an exposure of about 1/10 to 1/5 of a second. That's all. Try not to have the exposures too high because you might catch some errant cirrus or other weird stuff that might be out there. Here's an example of where the sun being 15 degrees below the horizon, with the NLC saturating that little sliver of twilight that exists here. This picture is taken by Tiana Goddard from Chariton, Iowa, at a latitude way down at 41 degrees north. So there's the star Capella about to set, and off to the left of that is the constellation of Gemini. Now, when you get NLC covering a large portion of the sky, you want to take a picture of it. You need like a wide-angle lens or a fisheye lens because they can cover the whole sky. Conversely, get a telephoto lens out or binoculars to catch the fine filamentary details that these clouds often exhibit. This display went right down to the horizon. Another name for NLC is PMC, or polar mesospheric clouds. Now, PMC occur right over the polar areas. So the North Pole in the summer, Southern Hemisphere, they also have the clouds during their summer from December to February. So it's a mass of clouds that's covering the poles, and when they start to drift down towards the equator, we see them as NLC. This picture is taken by the SIPS imager on the AIM satellite, which operated from 2007 to 2022. SIPS imaged the clouds in strips, and over a 24-hour period, it covered the entire pole. So this particular image is from a 24-hour period on June 18th, 2020. Over the 17 years that the satellite operated, we figured out from that NLC occur somewhere over the Northern Hemisphere, an average of between 90 and 100 nights in total, centered from mid-May to mid-August. Now, from any one location, you don't see 90 to 100 occurrences of NLC. it's quite a bit less, mostly because of weather, but other factors as well. This ISO map was created from observations from weather stations from the 1960s and 1970s, and it shows lines of equal incidence of NLC. The best place to see NLC in North America is right around Slave Lake, because that particular site had the most sightings over that approximately 11-year period. But generally speaking, over in northern Alberta and BC, even like down to Edmonton, it's the best place on the whole continent to see NLC. A bit of an anomaly there at Churchill. As you go further south, considering they're forming over the poles, they're just too far out of range as you get into the U.S. You go far to the north, you don't see them until the season ended in August, because of course that's the midnight sun is covering the poles during June and July. Mike Noble, who we lost in 2022, was a prolific NLC observer. He used his camera to photograph the faintest of displays and also drove around during cloudy nights to try to catch holes in the sky where he could observe NLC. He's holding one of his own photos of NLC here. And as a result, he regularly had sighting totals into the 30s each year. His record was 49 active nights in 2018. Sometimes NLC, large masses of it drift so far down the south that they can see it well into the U.S. This photo is by Thad Starr from Pleasant Hill, Oregon, latitude 43.9 north, 2019. A spectacular display of NLC. The record for North America is Don Davis from Joshua Tree, California. He's at 34.1 north. So that's the current record for NLC. This is his photograph here. This is the automated camera at Villeneuve Airport. These cameras are set up at airports so pilots can dial into it to find out what the weather's like before they hit an airport. And these cameras are located at airports all over North America, really. As it turns out, they're sensitive enough to see NLC. Here's an image from Fort Chipewyan of NLC, very easily visible, this display. Photo courtesy of NAV Canada. And this photo is courtesy of the FAA. It's the automated camera at Kodiak, Alaska. A nice display with beautiful streamers of NLC. Now, one of the neatest things about NLC, the most intriguing, is that we only started seeing them in 1885. Well, let's go back 2 years before that to 1883 and the Krakatoa eruption. Krakatoa is an island in the Sunda Strait between Java and Sumatra. On August 26, 1883, there was a violent explosion with a volcanic index of 6, the equivalent of 13,000 Hiroshima detonations. Some 200 million tons of water vapor, up to 500 million tons of water vapor was thrust up into the atmosphere, as well as 25 cubic kilometers of dust. 165 villages were destroyed, 36,000 people were killed. For 2 years after the eruption, weird sunsets and afterglows were seen all over the world. They were most pronounced in November, December 1883, and consisted of colors like copper, magenta, blue, and green. The poet Gerard Manley Hopkins wrote, "More like inflamed flesh than the red tones normally seen with twilights. The glow is intense. It covers the entire sky. It's been mistaken for the reflection of a great fire." So the afterglows inspired many paintings. This one's by William Ashcroft from November 26, 1883. A year later, there were still weird purple glows occurring. This painting's by Edward Loesch Lowish in December of 1884 off the coast of South America. So let's go back to 1885. World population was 1.4 billion. What other things happened in 1885? The cafeteria was introduced in 1885 in New York City, although this picture is not from 1885. Dr. Pepper, the soft drink, was introduced in 1885. It says it right on the bottle. And to commemorate this fact, we have some complimentary bottles of Dr. Pepper that we'll be giving away at the break. So, 1885, Europe. We're about to see the result of up to 500 million tons of water vapor being injected into the mesosphere. It was determined that the transport time from the surface to the mesosphere is about 2 years. So 1883, and here we are at 1885. Considering where NLC usually form, we could expect them to be seen in a latitude zone from about 50 north up to approximately 60 north up here. So let's see exactly what happened. Very first observation, June 8th and 9th, by the astronomer T.W. Backhouse, British astronomer who happened to be in Kissingen, Germany at the time, latitude 50.2. Very first observation of NLC, and just a single one. 2 nights later, Václav Láska, Czech geophysicist, saw NLC on June 10th, 11th. 2 nights after that, Vital Saraski, astronomer at Moscow, noted NLC. Saraski was a pioneer in the field of instrumental photometry and achieved great accuracy in his measurement of the brightness of stars. He went on to be a prominent NLC researcher. After a bit of a lull, there was an explosion of activity on June 23rd, 24th, all over Northern Europe. This fellow here, Ernst Hartwig, German astronomer who happened to be in Tartu at the time, 2 months later, had another significant discovery. Not something to do with our galaxy, but in another galaxy. Any guesses what he discovered? The first supernova outside our galaxy is a supernova in Andromeda. And then the 2 dots in Germany that are touching each other, the lower one is Otto Jesse from Stiglitz. Jesse went on to be an eminent researcher of NLC in his own right, constructing an NLC observatory. 24th, 25th, more observations. 25th, 26th, 26th, 27th, both Saraski and Jesse. 27th, 28th, and a cluster of observations at the tail end of June, beginning of July. July 6th, 7th, we had an observation by Jesse in Germany, and also Robert Leslie in Southampton in England. Now, Leslie is the first one out of all these other ones that we had who was not a scientist. He was a painter. It's kind of interesting to think that in this day and age, if we have more access to the means to report stuff, now anyone could just take a picture of NLC and put it on space weather and have instant fame. But back then it was a totally different situation. Leslie made his reports to the journal Nature, which had just started out a few years before. Now, he had an observation in 1884, which we attribute probably not to NLC, but to the other phenomena associated with Krakatoa. He said that this was at times very remarkable in the early part of July this year, when we had some of the strangest white sunsets I've ever seen. The sky around and where the sun had set, looking almost ceiling-like in its opacity, upon which soon appeared numbers of weird small cloud forms, at times very regular, like ripple marks in the sand, or the bones of some great fish or saurian embedded in a slab of stone. following year, on July 6th, he made his own observation, which in this case was probably an LC. He wrote, ever since the sunsets of 1883 and last year, there's been at times an abnormal glare both before and after sundown, but I have seen nothing in the way of twilight effects so strange as that of Monday evening the 6th, when about 10 p.m., a sea of silvery white cloud lay above a belt of ordinary clear twilight sky, which was rather low in tone and color. These clouds were wave-like in form and evidently at great elevation. So here we have it, the NLC observations from June 8 to July 6, 1885, the very first observations perhaps of this phenomenon ever. Going through the rest of July, there were other sightings for a total of at least 21 active nights in 1885. Now, considering the geographic breadth of Europe, 21 nights in a season is actually kind of low. But this was the very first year they were seeing that. You have to consider that. As far as the possibility of seeing NLC before 1885, our scientists mentioned, just starting with RASC, he said, I've been repeatedly objected that these clouds may have existed before 1885, but they were not noticed. As for me, I can say that I have been observing with the photometer since 1875, and I regard these observations are difficult and very unpleasant, solely due to the special attention focused on the slightest clouds or a fine mist. It would be pretty hard for me not to notice the phenomenon, which sometimes covers no more or less than the entire vault of heaven. Out of Jesse. I observed often in the summer of 1884 the purple light and carried out a greater number of measurements on it. The phenomenon of NLC would not therefore have escaped my attention if they were visible at that time. There were efforts to look further back earlier than 1885 for observations of NLC that might have occurred. There are possible ones from 1781, 1783, and 1850, but they were rather vague descriptions. This is a painting by the Scottish painter William Dyce, Francesco de Rimini, from 1845, which seems to have some strange illumination over here, but whether or not he actually saw NLC is open to speculation. So with the existence of NLC, are we looking at the after effects of a single big eruption that happened 142 years ago? Since then, there have been slight volcanic enhancements in activity, the most recent just over the last few years. The 2019, 2021, and 2022 seasons were the best years for NLC we've had in a long time. Our research group, headed by Peter Dahlin of the Swedish Institute of Space Physics, proposes that a quartet of volcanic eruptions, including this one, Klauschiskoye in Kamchatka, along with Shiveluch, which is also in Kamchatka, and Kalbuko and Sabankaya in South America, in concert, put so much water vapor into the atmosphere that it lowered temperatures and increased water vapor over a number of years, which caused that bump in activity. How about Hunga Tonga? That occurred in January of 2022. Considering a transport time of 2 years, 2022, 2024, 2024 should have been a good year, but the last 2 years, 2023 and 2024, have actually been kind of lousy years for NLC. But activity has started really well this season, so maybe this is the year that we see the bump from Hunga Tonga. So over the last 200 years, there's one other eruption we should probably talk about. What was, let's say, in the last 250 years, what's the biggest volcanic eruption we've had? Any guesses? How about Tambora? Yeah, okay. Tambora, 1815. Supposedly, that eruption charged the stratosphere with 2,000 million tons of water vapor, twice the amount that's already present in the stratosphere, and yet there were no observations of any weird phenomenon afterward. Very strange. It could be that maybe NLC started off really faint and they're starting to just over time get brighter. Gary Thomas and his colleagues in 1989 wrote a paper stating that above the average twilight brightness background, NLC have been increasing, and this where they intersect corresponds roughly with about the year 1890. And so they propose that the NLC are going to continue to get brighter and brighter. Why are they getting brighter? Well, it has to do with methane rising up from the Earth's surface from various sources, but mostly because of the increasing population of the planet. When the methane reaches the stratosphere, it gets broken down, and water vapor is one of the components. The water vapor continues to diffuse up, and that's the water vapor that causes the NLC. More methane, more water vapor, brighter NLC. So definitely a greenhouse gas connection here. So we talked about Europe. How about the other continents? When did they first see NLC? Now, although Asia is a huge continent that covers quite a bit of the poleward areas, I'm not sure exactly when the first observations of NLC were in Asia. Africa, it's just too far away from the poles. Australia, same situation. Although there are a few islands to the South Australia and New Zealand where it would be possible to see them. South America, first observation of NLC was in 1888, so kind of in that same time frame. The area of Patagonia is far poleward enough for people to see NLC. Problem is, there's only about 2 million people in that entire region of Chile and Argentina. There are, however, 8 million sheep. Now, wouldn't it be nice if sheep could talk and recognize NLC for what they were? We might have a situation like this. So we have our three friends. That's Pedro. That's Paco. And Miguel in the middle. Miguel. Paco, are you awake? Paco. Miguel. Pedro, are you awake? Sí. Mira, nice display of Noctilucent clouds, eh? Not bad. South America. Then we get to North America. The first observation of NLC in North America didn't occur until 1933. We had to wait 48 years before our first observations, and they were made by the geophysicist Ernest Vestine, who was studying the aurora at the Minuk Observatory, north of Edmonton, just not far away from Athabasca. On the night of July 20th, 1933, he was out photographing and he caught the NLC, the very first observations in North America. He published his observations the following year in the Journal of the Royal Astronomical Society of Canada. The top image is about 12:30 in the morning, second one at 1:40, and the bottom one was at 1:50. So 48 years later. Ernest Vestine's only son, Henry, would accompany his father on canvases of black neighborhoods in the US in the search of blues recordings, a very eclectic pair. Henry later on went on to be a guitarist in one of the iconic hippie bands of the 1960s. I asked this question back in 2017. Anyone remember who this guy is? Or what the band was? And Heat. Yeah. So remember I was saying when you're taking pictures of NLC, try not to get the exposures too long because you start to see weird things. Here's what happened one night. After Vistine's observation, it took another 23 years before the next observations of NLC, which were made by Julian Kaniski, the weatherman for CFRN, who saw NLC on four consecutive nights, end of June of 1956. The aforementioned Queen Elizabeth Planetarium's first director, Ian McLennan, who's still consulting at the age of probably about 90 years old. He saw a few displays of NLC in the 1950s. Longtime RASC member from Edmonton, Franklin Lodi, photographed NLC in 1962, and hence may have been the second person on the continent to photograph NLC. So another 23 years we had to wait for NLC. I kind of figured that why not look at an area where there's quite a bit of population in the first half of the 20th century to see if they saw NLC there. So I thought Alaska, they don't see their NLC until August, towards the end of the season, but there's still, there's a fair amount of population there. So I went looking through newspapers to look for any kind of reports that sounded like NLC. This is the closest that I got. From Fairbanks Daily News Miner, September 14, 1914. On the 21st of June, the sun set at 10:10 p.m. and rose at 1:40. The scattering clouds were aglow during the entire night. But Fairbanks is at 64 north, only 2 degrees below the Arctic Circle. And on the longest day of the year, the sun only gets about 2 degrees below the horizon. So the clouds they're talking about here are probably just the clouds right after sunset, and that's as dark as it got all night. This is Benson Fogel, NLC researcher from University of Alaska in the 1960s, who wrote a couple of seminal reports and got a network going of weather stations in the 1960s and 70s to monitor NLC. This picture was actually taken, it was actually in Stardust because Benson Fogel did a talk on NLC at the meeting on June 3rd, 1965, almost exactly 60 years ago. So at the same time, actually, the Gemini 4 spacecraft was orbiting the Earth. And on that very day, June 3rd, something very significant happened on Gemini 4. Any guesses what happened? Exactly. And what's the astronaut's name? Very good. Excellent. So I'm thinking that during his talk, there was someone in the U of A sports department's art department who was so impressed with his talk that he decided to use Fogel's likeness in the for the mascot for the U of A. Booba! You see the similarity? The kind of cynical smile, the deep set eyes. Anyways, in one of his reports, Fogel had this very interesting graph. He went and tried to find all the global observations of NLC, starting from 1885 and going all the way to about 1965. Notice that right after 1885, the incidence went down and stayed that way until well into the 1950s. Why? Was it because of lack of observations, or was there an actual decrease in NLC? So 1885, boing, straight down already. And then the similar observations were until it was about 1956. The big bump in 1957 was because that was the International Geophysical Year. There was all kinds of observations going on, so they were obviously looking for NLC then. So very intriguing. Fogel, in one of his reports, said the first recorded recognition of observed clouds was made by T.W. Backhouse on June 8 of 1885. Doubtless, such clouds had been noticed earlier, but the published accounts are not sufficiently definite for them to be identified uniquely as NLC. So Fogel was of the opinion that NLC were probably there all along. So Vogel's program is indicated by the red line here, observations from 1964 all the way up until 1977. So this number of annual sightings range from below 25 to almost 60. So quite a range. Now we get to my role in this whole enterprise. So I started observing in the mid 80s for NLC. The British Astronomical Association got wind of this and suggested to me, they asked, we've got a network going at the UK for the last 20, 30 years to monitor these clouds. Why don't you get something started in North America? To which I replied, okay. So NLC Can-Am, the network to observe NLC, was born with the intent of simply keeping track of NLC from year to year. And that's what the black curve is. The green curve is actually corresponds to the sunspot cycle. Supposedly, when we're at sunspot peak, it warms up the atmosphere so that not as many NLC can be seen. That seems to be the case kind of right here in the 60s. Conversely, when at the minimum, that's when you see lots of NLCs. Although with some cycles, it doesn't quite work out that cleanly. So the black curve is our observations from 1988. On this graph, it goes to 2014. And when we started in 88, I got a bunch of weather and flight service stations to start observing. But the majority of our observations were made by amateur astronomers and weather watchers, including many RASC members, including many people in this room. And we owe a debt of gratitude to all of the people who have contributed observations over the last 37 years. Thank you very much. How about a show of hands? So that's the situation on this graph, at least of 2014. As you can see, there's quite a bit of variability in both curves, all the more reason to be keeping track of these clouds. This is a continuation of that graph. This little bump here could very well be that enhancement from the volcanoes. Although, as I mentioned, 2023 and 2024, the activity has gone down again. Now, to get a really good idea of exactly what's going on, you need consistent observations from one site, or preferably even more than one site, that has a rigid regimen and observes for a long period of time. For us, that was the L'Orange Flight Service Station in northern Saskatchewan. They had an excellent program going from 1990 to 2013, a total of 24 years. So the green curve is their observations over that 24-year period. Their average was somewhere around between 7 and 8 sightings per year. The blue curve is the weather-corrected curve. The black curve is the one that we saw in the previous slides showing all of the observations. So as you can see, very consistent numbers here. Activity is not going down much. It's not going up much. It's kind of just staying the same. We've determined that there has been a very slight increase at L'Orange, but it's not statistically significant. We have corroborating observations from Vilnius, Lithuania, and Moscow, showing the same types of results. The way to go, obviously, though, is to have automated cameras. You turn on an automated camera at dusk, let it run all night long, taking a picture like once a minute, and then do that all season long, and you get a great record of what's going on with NLC. Unlike me, automated cameras are reliable, never break down, and they don't complain about getting up at 3 a.m. to look for NLC. And they're sensitive. As I mentioned, yeah, the best time to observe NLC is from check at midnight and check again at 3 a.m. So the midnight's not too bad. It's the 3 a.m. Sky check that's a bit of a problem. So this is Athabasca University. And we've had a dedicated camera here since 2006. Run by the aforementioned Peter Delling and also Martin Connors and Ariel Raju, who are operating the camera right now. It's part of a network of cameras stretching all over the 54 latitude, 55, 56 latitude all around the world at places like Sweden and in Russia. And we've had quite a few research papers resulting from the observations of this network since the beginning of the century. Here's a picture of an LC from Augo right there. It's situated southwest of Athabasca. Now, you'd figure that with a huge NLC display, if it's visible, that it would easily catch people's attention. But such does not seem to be the case in this picture. This picture is by Joshua Knutson at Fort Dodge, Iowa, latitude 42.5. Music festival is going on. Huge display that people hardly ever see an NLC there, but they're looking 90 degrees away at the stage. It looks like the only person who is eligible or interested in reporting this thing in the first place is the guy who took the picture. But that's all it takes sometimes, just one person. And then you got instances like this gentleman, Jay Broche from Glen Ullin, North Dakota, prominent aurora observer who saw NLC only for the very first time in 1993. Became interested and decided to keep an eye out for them. And he's seen NLC every year since then. Actually, an average of 3 to 4 displays. Pretty remarkable considering his latitude of 46.8. And this is one of his photos. Then you got instances of Mike Boschat, Halifax, latitude 44.6. One of our original observers in 1988. Mike kept an eye out every clear night of the season, but only on this particular night, June 12th, 2019, saw his very first display. It took him 31 years to see NLC. So obviously he was very excited that night. Mike and I co-author an information page for the Observer's Handbook that has info on NLC, and the URL for that is at the very end of this talk. Are there any phenomena out there that people thought they just became visible recently, but were probably there all along? Well, how about sprites, those electrical discharges from the tops of thunderstorms? They were only reported for the first time in 1886. They weren't photographed for the first time until 1994, but now everyone's taking pictures of them. But they were probably there all along. So it could be said that each one of us might fall into one of two camps when it comes to NLC. There's the big 8-5 with Saraski, who says NLC began in 1885. And then there's the always been there camp with Vogel and Guba, who say that NLC, they've always been there. Whatever the case, the debate is intense. Good luck in your efforts to observe these beautiful clouds. Here's some information. The daily DAISY images. You can browse those. The weather cams, you can browse those in almost real time. Here's some more info. Alistair Ling's nlcplanner.com is an excellent website with tools on to help you observe NLC. And then different places where you can report it from. Great, thank you very much. I can entertain questions at the break when I'm handing out the free Dr. Pepper bottles. Thank you.
Thanks, Mark. Much appreciated. We'll get Frank over here to get us going back on our next presentation, and which I prematurely started before Mark. Gina Payzant will be presenting on a film that she produced and we shot last year. And she will be giving us a presentation on the background of the movie and what it took to get it produced here in Edmonton. It's still being edited, and we actually have a couple of the actors that were involved. We actually have the actor who played Galileo, Mark Andreyko. Please stand up. And Dan Schiff, I think you just left to go to the washroom, so we'll catch him later. Okay, so Gina, if you don't mind coming up.
Thank you, Clayton.
You're welcome.
Hello. Boy, thank you so much for coming out tonight. I know we've got a little bit of competition, but thank you for being here. I'm really pleased to be here. So I'm seeing the images of the Queenie Planetarium. That's where it started for me. That's where I got my interest of observing the night sky. Anyhow, I was pretty fortunate. My late husband, John Payzant, was a great lover of the night sky and of observing it. And I can't tell you how happy I am that we have with us tonight his 16-inch Dobsonian telescope. And I'm happy to see it. The last time we used it, John was really into Messier objects. And I'll never forget the first time I saw star clusters. How impressed I was. It was through that instrument that I realized one thing. I made an observation that every single feature in the night sky wasn't just a pinpoint of light. Every single feature in the night sky was different. It had its own personality, its own character, if you will. And anyhow, a lot of fond memories associated with that, and I'm proud to have it here on display tonight. Galileo through today's lens. It started off in the late 1980s as a play, and around about that time, I was a playwright. I became a science teacher in about 1990, and when I was studying, it took me a year and a half to get my B.Ed. I had some other degrees, so I was able to get it quickly. I had to take a media tools for education course. And of course, the computer was the new device that we were being taught to use in the classroom. And I was a little concerned because we were taught how to use it, but we were not taught about the applications that were possible. And I could see this incredibly powerful tool. And I was very concerned that we weren't, as teachers, given instruction as to how to use it. And I began to think, well, if this continues, who's going to be in charge? So I got to thinking a lot about technology at the time. And I guess I developed the idea that perhaps the more technology we have, the more philosophy we need. Remember, I'm a product of 2001, Space Odyssey, and we all know that story. So Galileo through today's lens. I chose Galileo. Many consider Galileo to be the father of modern science. It's arguable, I suppose, but he's certainly the father of a scientific method. So I started my journey with Galileo. So let's proceed. The project is complex, and I thought, well, this is the single best, very succinct description of my film that exists. And I just signed contract last week with the National Film Board, which huge thrill for me. The project description goes, the central theme of Physics for Poets is based on the idea that the more technology we have, the more philosophy we need. The setting is one night in 1633, Galileo prepares to travel to Rome from his home in Arcetri near Florence. This is his third and final request he has received to appear in front of the Holy Roman Inquisitional Council. In the night, various forces visit Galileo. His daughter, Sister Maria Celeste, offers comfort. His student, Viviani, presents an escape plan. And colleague Torricelli advises an easy acquiescence. Kepler, dead the past few years, conjures humankind's changing views of the universe, along with dire predictions and warnings of what happens when science and technology lose sight of itself. Physics for Poets is structured with 10 scenes, culminating in Galileo's return home from Rome in 1634. Physics for Poets was shot at Film and Video Arts Alberta Society Studio B here in Edmonton, employing that space's large white cyclorama, allowing period carpets and set furniture to appear to float in time and space. Costumes were historically accurate in terms of texture and line. Props were carefully curated to reflect the period. Inspiration was taken from early CBC black and white productions of great plays such as Hamlet and Oedipus Rex, where emphasis was on text and character. However, in Physics for Poets, we have the advantage of color. The jewel tones of the velvet cloaks add interest and style. The sole set piece in the white cyclorama abyss is a large window which appears to float. It is through this window that we see what Galileo sees through his lens, and the beautiful yet sometimes frightening dream visions that Kepler conjures. Galileo's nightmare sequence and his speech of abjuration were shot right here in this planetarium at the Telus World of Science Zeidler Theater Planetarium. Kepler's vision of Viviani and Torricelli as modern-day scientists was shot at the University of Alberta Department of Neuroscience. And you're going to see all these. I work, by the way, with Jared Paul. I'm with Real Mensch Studio here in Edmonton, and we prepared a trailer especially for tonight. So you are the first audience to see the trailer for Physics for Poets, and I'll save that for the very end. Okay, so what I've got here on the table, thank you, Clayton. First of all, this is a replica that I made of Galileo's telescope. I do have a photo that will show, hopefully, of Galileo's actual telescope that I modeled this off of. I did get to spend time at the Galileo Museum in Florence. I actually got to hold the real Galileo's telescope, which was really something for me. Okay, on the table here, I've got an assortment of books. And this is just a small portion of, this represents just a small portion of the research that I did. I consulted every book and article that I could find about Galileo, but I distilled it down. These were really, really important books. Here we are at the Galileo Museum in Florence. There was an awful lot of globes, as you could imagine, of the time, and armillaries. A lot of them too. Okay. These were Galileo's telescopes. The lower one is this. And originally it was red and brown, and it's faded somewhat. The interesting looking thing below the telescopes is a very fancy case. And in the center of the case is the lens from Galileo's telescope. And a curator dropped the lens, I think it was 1866, and cracked it. So I was able to see the actual crack in the lens, but it was nice to see Galileo's actual lens. Okay, here we go. This is what really got Galileo in trouble. This is the This is the book that we used in the film. The film, by the way, I should mention, is a historic docudrama with elements of magic realism. It is historically accurate. This is a modern version of Two New Sciences. This is the book that got Galileo into trouble because it offered proof. Now, when I say proof, you know what I'm talking about, of the heliocentric as opposed to the geocentric universe, right? I don't need to go into that. This is, anybody want to guess what this is? It's in the Galileo Museum in Florence. It's one of their treasured artifacts. It is Galileo's middle finger from his right hand. And I deliberately chose this shot. I took it, and it's not a very good picture because of the glare, but I didn't think you'd want to see all the detail. Yeah. Anyhow, there you have it, Galileo's finger. I think it's appropriate that it's the middle finger in the right hand. What is it?
I think that's the one he used at the Inquisition.
Yeah, it is. It is. Okay, this is the exterior street shot of Galileo's villa. And Galileo lived just south of Florence, just across the river in Archatri. And here when you walk into the villa, there's a bit of a vestibule, and those doors will take you right into the living quarters of the villa. By the way, this is closed to the public. It took me several months to arrange for permission. And once I got permission, of course, I was there for the day, and they were terrific. They brought me refreshment and food and made sure I had everything I needed so I could take pictures. This is Galileo's bedroom. Beautiful window. The floor, brick floor is original. The walls are original. And I didn't take pictures of the rest of the room because it was very, very plain. It was just a room with the plaster. But the key feature in the room was that beautiful window. Before all the trees grew large, Galileo could stand in that window and look across the road and see San Mateo, the convent where his daughter, Sister Maria Celeste, lived and worked. She was the village apothecary, and she looked after her father, providing him with various pharmaceuticals of the time, and looked after his linens, supervised his food, and they were very, very close. And Galileo wrote that he was proud of his daughter because she possessed an uncommon intellect. So the two of them were close. She was his confidant in so many ways. Okay, what's up next? This is Galileo's study, and this is how they've decorated it, for the odd person they let into the villa. And I found this valuable because it really helped me when it came time to design our set for the film. And of course, you have the phases of Venus on the table. That's very important. Okay, yes, please. This is Galileo's table and desk. There are table and chair, rather. They're pretty sure that the chair is original to the time that Galileo lived in the villa. They're not sure about the table, but they're pretty sure that if that's not the original, his table desk would have been very, very close. So I made efforts to duplicate that as close as I could for our film. This is another model. It looks a lot like mine, which makes me happy, but a beautiful mahogany stand. So yes, is a model of Galileo's telescope. And you can see the window behind, and it's got sort of two places to sit. That room was later occupied by Viviani, who was a student of Galileo, and Torricelli, who, of course, invented the barometer, who was a very good friend of Galileo. When Galileo returned from his ordeal in Rome, the two men, Viviani and Torricelli, looked after him. And this was the room where they lived in until Galileo's death. Before I talk about that, I just want to talk a little bit about our replica. We were very, very lucky to have some folks who actually worked for Netflix and other we were very small budget, okay? But we were lucky to attract some people who were used to working with much, much larger budgets because they liked the script. So they said, anyhow, I made the telescope, and Larry Kelly was one of those talented people that came on board, built the stand, and I think he did a terrific job. You'll see more as we proceed. This was such an incredible thrill to be in Galileo's loggia. This is where he did much of his observation. Absolutely beautiful space. And if you know a bit about Galileo's personal life, you'll know that he loved gardening very much. And very often he would go out and garden, and he would wear farmer's clothing. And if somebody came to the villa with deliveries, he would pretend to be a farmer or a worker in the gardens. And he enjoyed doing that very much. So I was pretty happy to be up there where Galileo stood. This is the view from the loggia looking down into the villa, and it gives you a real sense of what his home looked like. And again, most of it's original. The weather there, as you know, it's very mild. They don't have the severe weather like we do. So much of it has survived over the years. This is the third floor that Galileo had built onto the villa, and it was his indoor observation room. So no matter what the weather was, and Galileo did suffer from arthritis, and if he had a bout of arthritis, he could go into this room and be a little bit warmer than the loggia, and he could have some night sky observation in this room. Okay, now I'm going to take us back to where we are now. And this was April 17, 2023. Frank Florian had the idea that I take the script, Physics for Poets, and we start to workshop it. Frank actually found a copy of the script in his desk. I think it was one of the original 1989 scripts that I'd given to him many, many years ago. And we thought, well, should we do it as a play? And I'd already been involved in filmmaking, and my studio was ready to produce it as a film. So the play didn't work out, but became a film. So here we are in this space right here. And this was a professional reading of the script. And it gave me a chance to workshop the script, start to make the adaptation for film, and do the necessary editing. And we have Dan, who's the second from the left, our Torricelli. Mark, you've met. And Timothy J. Anderson at the far right is our Kepler, and he couldn't be here tonight. Nikki Halowski plays our Sister Maria, and she's in Banff at the moment. Quinn Contini plays Viviani, and he's got an acting job tonight. But you'll see them in the trailer. Here we are with our first reading before rehearsals. And you can see Nikki, our sister Maria, next to her. Is that Quinn? Yeah. Mark with his back. Ann Hill did she was my wardrobe master. Timothy J. Anderson plays Kepler. And you can see Jared, director of photography, cinematographer, and editor. And there we are. Our first production session was a game right here in this space. Thank you, Frank, for making all this available to us. This is a scene from Scene 8. Galileo is having a nightmare. I think I mentioned that the action takes place primarily in one night as Galileo's preparing to travel from Arcetri to Rome. And in this sequence, which we filmed in this space, he has nightmares. He has great fears about what might be facing him in Rome. Well, fearsome man. This is our Firenzola, the head of the Inquisition. And and here we have another inquisitor holding up the condemning, the damning book. By the way, I found an original of this book, one of the first editions, and it was available for only 400,000 Canadian dollars. I thought, wouldn't that be a spectacular prop? But we've got a female inquisitor, and it's actually quite chilling. Really. That's one place where I'm not historically accurate. There were no female inquisitors, but we have one. Okay, here's before we enter into the trailer, here's some production shots. The top image is our set, and we were very fortunate to have Studio B at Fava here in Edmonton, and they have a huge, giant white cyclorama, which is just, Dan, could you come up and show everybody your t-shirt? Okay, thank you. Okay, so a white cyclorama is kind of like this dome. It's just all white. There is no top, bottom, nothing. It's just white. And when the first day of the shoot, the technical crew came, the actors came. Don't go away. And they said, well, where's the set? And I said, you're standing in it. And they were like, what? And they said, well, what is it? And I said, well, it's everything and it's nothing. They were like, oh, yeah, that makes sense. Yeah. But it's all about time. That, yes, the play is historically accurate, takes place 1633 and 1634 when Galileo comes home. But the message is really about today and our lives and how we're coping or not coping with science and technology. So, Dan, we had a brilliant makeup artist, and she created these t-shirts as a gift. So the armillary was, you'll see in the trailer, which is coming up, that we have a lot of armillaries on the set, and it says, embrace the abyss. Because once the cast and crew got it, they understood it, that's exactly what they did. And they came up with this, and I thought, oh, this is great. So thank you. Oh, this is our Torricelli, by the way. Yeah. Okay, what are we on now? Galileo the top image, he's giving his speech of abjuration. I'm doing some directing. There's Firenzola again, below Firenzola, another brilliant inquisitor, Mark in makeup. There I am on the lower left. There's Clayton in the background. And here we go with another the top image is Galileo's speech of abjuration, Galileo in makeup. And then to the right is Jared and I crawling around in the dark, which you do a lot of when you make films. Okay, the top image, the top left is Viviani, Galileo's student. The top right, Sister Maria, moving down, Kepler. Nobody can see Kepler, by the way, except Galileo. The next shot is, you see the set. You see the white cyclorama, our lights. There's Larry Kelly on the left. There's me on the right looking through the monitor, which is what I'm supposed to do. Then the bottom on the left, Kepler tormenting Galileo, who's just trying to get a little rest before his journey. And Sister Maria, the bottom right, with Viviani. Okay, here we go. Kepler with the telescope. Kepler and Galileo with the telescope, upper left. Torricelli. I'm talking with Mark. And another picture of the set, again, showing that it's just white. We had one set piece, and that was a window made by Larry Kelly that appeared to be floating in space. And when that window opened, it revealed the universe, whatever universe we needed. And we could see what Galileo sees. Okay, the three men, Galileo with Viviani and Torricelli at the top. Again, you'll see more of that in the trailer. More set are Kepler, who, remember, is dead. There I am at the bottom. Oh, I should mention before we move on. Yeah, let's just stop it there. Okay, the graphics or the font for Physics for Poets. I'm working with a designer in Germany, and he has developed that font from Einstein's handwriting. So we're going to be using that font as the graphics for the film. Okay, time to watch the trailer.
What was it like the first time? First time for what? The first time you lifted the telescope to the heavens. You have not only set the earth adrift.
God chose you as his vessel. He deemed ready the knowledge that the earth moves.
You have effectively transferred the power from his hands into our own.
If you, Galileo Galilei, fail to travel to Rome to meet with the Council of Roman Inquisitors, we will see it as necessary to dispatch guards to escort you to Rome.
When the time comes in Rome, you will do what is best. But for now, tell me that you go with God.
Which is the more cowardly act? Fleeing the Inquisition or confessing to that which we know is not the truth?
Your father devoted his life to science. For what?
Don't forget, Virginia. Burn the letters.
You have demonstrated well that the earth moves. But are you prepared to demonstrate that 1,600 years of church doctrine is wrong?
What is she doing? Praying. I know that. Why?
Let them bring you to your knees for the moment. so you can come home and carry on.
Do you fear I will burn?
Have faith, Galileo, and come forward, for such is the force of truth.
If fear does indeed motivate our actions, do we not move dangerously outside the realm of logic and reason? And you, my friends, are physicists, scientists. Remember that.
Oh, they can't see me. The stars are bright tonight, my friend. Come, look.
You are the stuff of dreams.
Stop it. I'm merely offering you an amusement, a diversion to distract you from your dilemma.
You are my dilemma. Where is my God?
Vivian!
He would never lie to save his skin. Would you?
Of course not.
Though the flames lick the flesh, the spirit remains untouched. That is honor.
I, Galileo Galilei, aged 70 years, kneeling before you, most eminent and reverend Lord Cardinals of the Inquisition.
Mathematics is the poetry of logic. Your language of science. Useless!
Father,
You speak of faith. Whose faith? You betrayed me!
The stars grow even brighter, my friend.
Give it here!
Remember, this is your dream.
Poppycock!
Watch and listen.
Thank you. I hope when the film's made, you'll come and see it. I don't know where it's going to be. I have an option with National Film Board, so that's always a good sign. I'm hoping to get the film into science centers, science museums. I'd like to make it available for universities, schools as a learning tool. Anyhow, thank you for watching. And if you have any questions during the break, I'll do my best to answer them. Thank you. Thank you for
Very well done. Okay, we've got a couple quick items here to take care of, and then we'll have a short break and continue. I don't think anybody really wants to know what the score is, but. 5-1. 5-1 for Florida. Anybody want to know that it's 5-1 for Florida late in the third period? No, I don't think anybody did. Okay, so the observation group, Marie Hunt, if you got a minute, you can just you can give us a quick update there. We'll do a quick trivia and the break, and for the rest.
Thanks, Leighton. Yeah, just a quick moment. With people away and summer skies, we're not going to have the service group meeting, Zoom meeting next week. So June, July, we will not have a Zoom meeting, and then keep watching the website for August. In August, when dark skies start coming back. That's really all I wanted to say. Just today, I got an email, though, from Andrew Hollis, who used to be a member here. He's in Nova Scotia now, but he's selling his 8-inch Daub. It's here in Sherwood Park. If anybody is interested, and they can contact him for information about how to see it. And really, that's all. Thank you.
Thanks, Mark. Okay. Okay. Real short ones here. Which planet has a day that is longer than its year? How long is a day on Mercury and Earth days? How long is a day on Venus and Earth days? And which planet has a storm named the Great Dark Spot? A little bit of a tricky question there. Okay, we'll have our break, and when we try to keep a 5 to 7 minute time frame, you can talk with both Mark and Gina about their presentations, and then we'll get back right away. Thank you. Okay, we're getting started here again and get you guys out of here before midnight. Announcement. Well, we already did the Quelac Award, so we don't have to worry about that one again. So next up will be Susan Bram, who's on our Zoom call tonight, and she will give us a quick NPSP update. Susan, are you there?
Yes, I'm here, Clayton. Can you hear me?
Loud and clear.
Okay, great. The June issue of the Stardust just came out this afternoon, and there's an update in the Stardust. So I won't give you all the details, but I'll give you some of the highlights. We've got some new information about the Star Party, which runs, as you know, from September 16th to the 21st at Black Nugget Lake, which is also the location of our Black Nugget Lake Observatory. Since our May update, registration has proceeded extremely well. As of June 6th, there are only 2 unpowered sites left for camping. One is a tent site and the other is an unpowered site that can be used by an RV or trailer. So if you're still interested in being on the north side of the campground, get onto the registrations page on the Northern Prairie website and make sure that you've got a spot. All those planning to attend, whether you're coming as a camper or just coming out for the Friday and Saturday programs, we're asking you to register online in advance. This will assist greatly with our planning. The final deadline for registration, which includes campsites, t-shirts, and registration, is Thursday, August the 28th. So we still have lots of time before that comes up. We're happy to let you know that we have our third speaker, and Luca Vanzella has graciously agreed to be our RASC Edmonton Center speaker for this year. His talk will begin at 1:30, and he's going to talk about BNLO the first 2 years. And as many of you know, Luca is a longtime RASC member who served in various council roles, including president from 2015 to 16, and has been recognized several times, including the 2014 Franklin Lodi Award for Project of the Year for his Analemma, and the 2017 President's Award for Service to the Center. He is currently the club's fundraising coordinator and chairs the Black Nugget Lake Observatory Management and Operations Committee. For the past 8 years, Luca has had an ongoing and deep involvement with the planning, construction, and operation of the BNLO. He is a keen visual observer and has gained international recognition as a skyscape photographer, focusing on images, including timescapes, featuring the moon, the sun, and the planets in the night, twilight, and daytime skies. Luca's talk on the BNLO will include the following highlights. First light, of course, was of the Unit-Drew telescope at the Northern Prairie Star Party in 2023 on September 16th. Luca's talk will present highlights from the first 2 years of operating the BNLO facility. Highlights include final commissioning work, significant enhancements, events at the BNLO, computer hardening, driving with Sky Safari, and memorable views through the Unit-Drew telescope. The talk will conclude with a progress report on the BNLO Internet project and a preview of the Planewave Observatory. So that will be our first talk, and we have provided descriptions and background to the speakers for the other 2 talks on the Saturday on our website. Just as a recap, Professor Huang Cheng, Assistant Professor of Physics, Department of Science, University of Alberta at the Augustana campus, is going to be presenting on the mysteries of the supermassive black holes in first galaxies. And Alan Dyer, who I know is on the call tonight, is going to be presenting at 4 o'clock on the Saturday on the Northern Lights, the science behind the spectacle. Alan is also going to be he's graciously offered to give a 90-minute workshop on the Friday afternoon on capturing terrific nightscapes with a focus on the aurora and Milky Way. We're going to be posting our event schedule and t-shirt design soon on the NPSP website. Check back for updates later in the summer too. And if you have any questions or need more information, you're welcome to get in touch with any of us on the planning team or through the email address npsp@edmontonrasc.com. Thanks a lot. And I don't know if there's any questions, but looking forward, we're getting very excited about this event and looking forward to seeing many people out there this year. Thanks, Clayton. Back to you.
Thanks, Susan. Okay. Next we have is Mark Zalcik again, and he is going to be talking about Book of the Month.
Thank you. Hello again. Before we talk about Night Watch, there's one photo credit that I still have to give for my presentation, and it was the one with the sheep. That picture was taken by Linda Davison from Beckermet on the east coast of England, even though we were assuming that the sheep were from South America, but whatever. So that was Linda Davison. Thank you, Linda. The library is open about half an hour before and half an hour after each meeting. And whoever takes the book out tonight can basically have it all summer long. Rosemary Ball is the co-librarian, and she was busy before the meeting digitizing our catalog, and she made significant headway so far tonight. Shout out also to Berta Beltran, who puts the Book of the Month on the center website. This month's Book of the Month is Night Watch by Terence Dickinson, and Rosemary has provided a review of it. Rosemary writes, I'm a newcomer to astronomy, and like everyone these days, I started my learning journey by Googling. There's a plethora of information out there, often more than you need, want, or can deal with. What's important and what's just interesting noise. Even if you start out on a site that has accurate information at an appropriate learning level, it's seductively easy to start clicking on links and opening tabs. While they may take you to fascinating new places, hopping about won't necessarily advance your learning journey. Sometimes an article or website just wants to sell you something. So when you're still striving for basic competence on a subject, a good book is worth 1,000 apps. That's because a book is finite. The author must go through the material and sort out what is necessary and what's not, then organize it in a way that is informative and engaging while keeping within the page limits. A successful introductory astronomy book will guide the reader from flailing novice to a stargazer with a basic understanding of the cosmos, all without requiring a battery or an internet connection. And that's what Terence Dickinson does in his book Night Watch, a practical guide to viewing the universe. Dickinson was a Canadian amateur astronomer long associated with the RASC. He was the staff astronomer at 2 planetariums and wrote over a dozen books and hundreds of articles. The first edition of Night Watch was published in 1983, with the final edition published 40 years later. Dickinson's goal was to unravel the mysteries of the cosmos and enable the backyard stargazer to become, quote, a naturalist of the night, unquote, capable of grappling with, quote, the chilling realization that the Earth is but a mote of dust adrift in the ocean of space, unquote. Dickinson says that astronomy is best learned step by step, and contrary to what many people think, buying a telescope should be the last, not the first step. Begin by becoming familiar with the night sky. He explains the universe in 11 ever-widening views. Picture a pebble thrown into a pond. The pebble is the Earth. The first ripple extends to the moon, the second to the inner planets, the third to the solar system, and so on, until the 11th and final view takes in the entire observable universe. The author then returns to the practicalities of looking up from one's backyard and getting to know the starry night through all the seasons. This coil-bound book includes star charts for binoculars and small telescopes that can be read outdoors with a red flashlight. Only then does Dickinson introduce the hardware of astronomy, beginning with the training wheels of binoculars, through simple and computerized telescopes, and finally to cameras and astroimaging equipment. In 200 pages, Dickinson covers the cosmic panorama that enchants stargazers from aurora and eclipse chasers to Messier catalog collectors and deep sky enthusiasts. Beautiful images and crisp, readable charts and text make Night Watch the best general interest introduction to astronomy. His 5 editions have sold over 800,000 copies. Dickinson created an accompanying website, nightwatchbook.com, where you will find animations of sky motions, top 10 tips, and links to websites and YouTube videos. Balancing accuracy with accessibility, Night Watch retails for about $40. Spend time with this book instead of money, equipment, or complicated apps, and you will be well launched on your stargazing journey. 5 stars. Thanks, Rosemary, for that review. And we have 3 copies of this book in the library right now. Thank you.
Thank you, Mark. Yes, and I do have a copy of that last edition, and it's an excellent book, and I would encourage anyone who's really interested in learning the night sky to pick that book up. Okay, Tom Owen. We are doing Astro Imaging Corner.
So our first image is by Alan Hobbs. It's M8, the Lagoon Nebula. And he writes, the Lagoon Nebula is a giant interstellar cloud in the constellation Sagittarius. It's classified as an emission nebula and has an H2 region. This was taken at the Casitas de Gila guest house in New Mexico near Silver City on March 24th. The astrophoto has 40 subs times 60 seconds exposures for a 40-minute integration time. The astrophoto was taken with my Celestron RASC 8 and ZWO ASI 2600 MC camera with an Optolong L-enhanced filter on a Skywatcher EQ6R Pro mount. And he calls it IC2118. As I mentioned last time, often there are multiple catalog names for images. It was processed with PixInsight and Photoshop. And he also says, all members of the RASC Edmonton Center are invited to the Casitas de Gila guest house in New Mexico. Oh, he didn't put that in. Okay. So Alan Hobbs, this is his next image, the Seagull Nebula, also known as M16. He says it's a young open cluster of stars. So it's actually, M16 is actually the cluster, which you can see kind of at the, I suppose, the head of the seagull, head of the eagle. No? What? Oh, the Seagull Nebula. Whoops. Oh, that's my mistake. I put seagull, not eagle. So it is the Eagle Nebula. Yeah. Birds of a feather. Both the Eagle and the Star Queen refer to visual impressions of the dark silhouette near the center of the nebula. An area made famous as the Pillars of Creation, imaged by the Hubble Space Telescope. The nebula contains several active star-forming gas and dust regions, including the aforementioned Pillars of Creation. The Eagle Nebula lies in the Sagittarius arm of the Milky Way. This astrophoto was taken with my Celestron Edge HD 8-inch with a 0.7 focal reducer and a ZWO ASI 2600 MC camera on a Skywatcher EQ6R Pro mount. It was taken on April 24th using Nina, 15 subs times 2-minute exposure. So that's a really great photo of the Eagle Nebula. So this is another one from Alan. This is NGC 4565. And he says this is an edge-on spiral galaxy about 30 to 50 million light years away in the constellation Coma Berenices. It lies close to the North Galactic Pole and has a visual magnitude of approximately 10. It's known as the Needle Galaxy, and it's not the only one that we know of as the Needle Galaxy for its narrow profile. First recorded in 1785 by William Herschel, it is a prominent example of an edge-on spiral galaxy. The astrophoto was taken with Nina on my Celestron Edge HD 8 with a 0.7 focal reducer, and again the 2600 MC camera on the EQ6R Pro mount. It's 20 subs times 3 minutes for 60 minutes total exposure, and taken at the Casitas de Gila guest house in New Mexico on March 31st, 2025. So Clayton had texted me earlier this weekend, I think, to say he'd like to see, and he thought it was a good idea if we could show some of the equipment that the astrophotographers are using. So I asked Alan, and this is his equipment. This is what he's been using to shoot those images. So next we have, sorry. Hans S. Johns, the Cat's Eye Nebula. The Cat's Eye Nebula, NGC 6543. He says it was exposed for approximately 10 hours in HAO3 and 1 hour in RGB for the star colors. The nebulosity was processed to taste in a modified HOO palette. The bright center object has a lot of detail, most of which eludes my scope, though Hubble sure shows it nicely, but I was happy with the amount of detail I was able to tease out. And here is his image of M92, the globular cluster M92. M92, by the way, it's kind of like, for those of us of a certain age, it's the Avis to M13's Hertz. I exposed it for 10 hours in RGB from my backyard, only to realize that a 1.5 hour exposure from a dark site I had taken a few years ago yielded an almost better image. I ended up combining the two data sets to arrive at the attached image and came away with a good lesson on how important dark skies really are when shooting natural colors in RGB. And that's a tremendous photograph of M92. So now we'll look at Hans's equipment. So this is overall sort of an overall look at everything, and then he's given a close-up of his actual camera rig. And there it is. So he's got the electronic focuser. He's got the, I assume that's a 2600 with a filter wheel. He's got the off-axis guider going. This 0.7 reducer. There's all kinds of things happening at the end of that telescope. So thanks for that, Hans. Now, we're going to conclude with a montage that Mark Zalcik put together of, yes, you guessed it, Noctilucent clouds. Okay, there we go. He writes, when a time-lapse sequence of Noctilucent clouds is constructed, the stately, mesmerizing pageant of the clouds is revealed. They are actually racing at some 150 kilometers an hour towards the west, i.e. the opposite direction of regular weather clouds. This movie was made using 7 sequences from 2022, 2023, and 2024 seasons, plus 3 still photographs. The prominent star in 3 of the sequences is Capella. In the 30-second clip at about the 2-minute mark, watch the bottom right of the frame at the beginning of the clip as the star Aldebaran creeps into view. In the first clip, the Edmonton police helicopter makes a cameo appearance as a brief flash. The final still photo, which is also the first NLC picture in my presentation, is from the magnificent display of July 1st and 2nd, 2011, using Kodachrome 64 slide film, no less. The same display was photographed by Rick Bram, who used one of his photos in the logo for the 2018 Northern Prairie Star Party. So let's see if I can get this going here. nice, Mark. My goodness. You know, Keats was right. Truth is beauty, beauty, truth. So, I'd like you all to seriously consider sending your images to Astro Imaging Corner. I'd love to see some new folks rather than the usual suspects, including yours truly. And if you would please check the RASC Edmonton Center page at the bottom left. You can send them to, just click on Astro Imaging Corner, send me your image, and I will feature it in our next presentation. Thanks very much.
Thank you, Tom. Just another thing, I don't know if anybody heard recently that we lost another pioneer in Canadian space exploration. On June 4th, Mark Garneau, our first Canadian in space, passed away, 79 years old. So Mark also, he was a minister and I think he was transport minister as an MP here out of Quebec. So sorry to see that and sorry to hear it. Trivia answers. Here we go. Which planet has a day that is longer than its year? And that answer is Venus. How long is a day on Mercury in Earth days? The answer is 58.6. Anybody get that? Without looking it up? I don't think so. How long is a day on Venus in Earth days? And that answer is 243. And this was the tricky question. Which planet has a storm named the Great Dark Spot? Not the red spot, but that was Neptune. Okay. Final announcements. Okay, here we go. Cartoon. I actually got two this time. First one, guy said, I'm an astronomer. Well, what do you do in the daytime? Well, I look at the sun. I don't know about anybody else. Okay, this is a good one. Does this beam only lift me? How do you avoid pulling up dirt and leaves and stuff? If I kick off my shoes, will they fall? My weight pulling your ship downward? What will happen if a bat flies through the beam? Hey, why does your ship have so many blinky lights? Are they? Moments later, the alien set me back down and left. I can relate to that. I have a 4-year-old grandson who just talks all the time. Okay, this is our last meeting before September, so our summer break. Next meeting will be Monday, September the 8th, 7:30 p.m. Not sure what our guest speaker list is going to look like, but keep an eye on the website and Facebook, and you'll find out. Other than that, I hope everybody enjoys their summer. They get out and do some observing. We got, as Susan mentioned, we have the MPSB coming up in mid-September, so we'd like to see a lot of people out there. We have a couple of events during the summer, not too many. I think we'll be involved in the July 1st. I believe there's something happening here with Telephoto Science, and RASC will have a table set up. And Jeff is going to talk a little bit about Milky Way days.
Yeah, just a quick announcement. On August 31st, we're going to be doing the annual Milky Way Day out at Elk Island Park. So keep an eye on the volunteer list. I will be posting something shortly, and we'll be looking for all sorts of people to help out with that. And as Clayton mentioned, we're doing something here at Two's on July 1st. That's already been posted on the volunteer list as well. So that's all I got right now.
Thanks, Jeff. So hope everybody has a great summer, and we'll see you all back here in September. I will call the meeting adjourned. Thank you.